Okay, one of the most interesting aspects of nature is change. And what we are interested in is not only the change, but the rate at which the change is taking place, or rate of change. Now we have looked at algebraic equations. We have looked at something like this, right? Y is equal to 3x plus 5, y is equal to x square, y is equal to sine x, right? We've seen many such equations. Now here in each of these equations, what is happening? For a change in x, or whenever the x changes, y also changes, right? So whenever there is a change in x, there is a change in y. Change in x, change in y. Change in x, there is a change in y. There is a change in x, there is a change in y. Yes. Now, how do we measure this change? Naturally, to be able to measure a change, we need to do some kind of a subtraction. Now, to be able to do subtraction, we need to have 2 points, isn't it? So, let's say we start off with a particular value. By the way, here the rate of change would be delta y by delta x. That is what is meant by rate of change, the rate at which y is changing with respect to x. So here, let's try to figure out. Now, we have a function, a general kind of function. Let's not be very specific. Let's say y is equal to f of x. Whenever there is a change in x, there is a change in y. Yes. Naturally, as the x value changes, the y value also changes. Okay. Now let's bring in this y to the other side, minus y. Now we know y is nothing but f of x. Yes. So now we have change in y is equal to this. But the rate of change is what? Delta y by delta x. So which means this we divided by delta x. Now here remember we still have 2 points of reference, but we want the rate of change at a particular point. Alright, so we have 2 points, but we are interested in only at this rate of change at this point. So which means we have to bring this closer and closer to the point of interest. So as it gets closer and closer to this, the change, this is the change, has to get smaller and smaller. The change in x has to get smaller and smaller. So how do we do that? We take the limit. So limit as delta x approaches 0 of delta y by delta x is equal to limit as delta x approaches 0 of f of x plus delta x minus f of x divided by delta x. Okay. So this gives us the rate of change at a particular point. Using this formula, what we are doing is we are making it so small. Remember, it can't be 0. Then those 2 points actually become the same point. But here in the formula we end up with a 0 in the denominator. And we have seen in limits how to make this disappear. Let's look at some examples. Let's say f of x equal to 3x plus 5. Okay, so let's look at the limit statement. Limit as delta x approaches 0 of delta y by delta x is equal to, now we substitute wherever x is there, we substitute x plus delta x. So limit as delta x approaches 0 of f, no, not f now, 3 times x plus delta x plus 5. Yes, that is this part. And now minus 3x plus 5 divided by delta x. Limit as delta x approaches 0, 3x plus 3 delta x plus 5 minus 3x minus 5 by delta x. Here minus 5, 5. 3x minus 3x get cancelled. So limit as delta x approaches 0, we are left with 3 delta x by delta x. Delta x gets cancelled. Now we take the limit. So now since delta x itself is not there, it doesn't matter even if we make it 0. So even if we make it 0, it becomes 3. Okay, or in other words, since it is a constant, the rate of change throughout this function is 3. Okay, let's look at f of x equal to x square. Limit as delta x approaches 0 of delta y by delta x equal to limit as delta x approaches 0 of wherever x is there, we have to take x plus delta x square minus f of x. F of x is x square by delta x. Limit as delta x approaches 0. Remember a plus b the whole square, x square plus 2x delta x plus delta x square minus x square divided by delta x. X square and x square get cancelled. Limit delta x approaches 0. Now here delta x is common, so we take it out. So we are left with 2x plus delta x divided by delta x. These two get cancelled, and now we can take the limit. When we take the limit, what happens? 2x plus 0, which is 2x. Let's take a cubic expression now. F of x equal to 3x cube plus 2x. Let's really make it a little bit complicated. Limit as delta x approaches 0, delta y by delta x is equal to limit as delta x approaches 0. Now wherever you have x, you have to substitute it with x plus delta x. So 3x plus delta x cube plus 2x x plus delta x. Remember, this is the first part. Second part is minus f of x minus 3x cube plus 2x divided by delta x. So limit as delta x approaches 0. Now we have to simplify it. 3x cube plus 3x square delta x plus 3x delta x square plus 2 plus delta x cube plus 2x plus 2 delta x minus 3x cube minus 2x, yes, divided by delta x. Limit as delta x approaches 0, simplified further. So 3x cube plus 3x square delta x plus 3x delta x square plus delta x cube plus 2x plus 2 delta x minus 3x cube minus 2x. 3x cube gets cancelled, 2x minus 2x gets cancelled. By the way, this is 3 times 3. This is 9. This will also be 9. Okay, limit as delta x approaches 0. Let's take things in common. So let's take these two. 9 is common, x, one of the x is common, delta x is common. So x plus delta x. Okay, plus delta x cube plus 2 delta x. Now let's take partial fractions. So let's take delta x delta x, delta x. These two get cancelled. This gets cancelled with this, so you're left with square. This gets cancelled with this. Now there is no denominator. Now we can take the limit. So 9x times x plus delta x. Delta x is 0, so x plus this becomes 0 plus 2. So 9x square plus, again let me repeat, this is an expression which will give us the rate of change or slope of the graph x 3x cube plus 2x for any value of x, right? So f of x is equal to 3x cube plus 2x. Yes, okay. So this is the function. This is the f prime of x. Remember, dy by dx or delta y by delta x can be written as f prime of x. This is equal to 9x square plus 2. That means if I want to know the slope of this function at x equal to 2, what I have to do? I have to find the derivative, and in this derivative I substitute the value of x. So 9 times 4 plus 2, 9 4s 36 plus 2, which is 38, is the slope at x equal to. So that's how the thing works. So which means we don't have to have any kind of data to figure out what the slope is. We don't even have to draw a graph to understand what the slope is. Purely algebraically we can figure out the slope at any point in a function, and that's a very powerful tool to have. Okay, let's do a trigonometric one. So let's say f of x equal to cos square x. Just start off as delta x approaches 0 equal to limit as delta x approaches 0 of cos square. Remember, wherever x is there, you have to put x plus delta x. So x plus delta x minus f of x. So that is cos square x by delta x. Now remember, cos square a minus cos square b is nothing but sin square b minus sin square a. So which means our limit statement becomes limit as delta x approaches 0 sin square b, that is x, minus sin square x plus delta x divided by delta x. Now this is sin square a minus sin square b. Alright, so sin square a minus sin square b is equal to sin a plus b sin a minus b. Right, so our statement becomes sin x plus delta x sin x minus x plus delta x divided by delta x, which is equal to limit as delta x approaches 0 sin 2x plus delta x x minus delta x by delta x. Of course, these two gets cancelled, so which means our statement becomes sin 2x plus delta x. Now sin minus delta x becomes minus sin theta. So minus, we bring it here. So sin delta x, and this denominator delta x, we take it under this. We can always take it like that because there is no addition subtraction on the top. Now we can take the limit. So limit, if we take it, we end up with sin 2x plus 0, and remember this whole thing becomes 1, so which is minus sin 2x. So Just remember to figure out an expression which will give you the slope at any point. You have to find the derivative of that expression, right? Derivative basically means delta y by delta x, or derivative is nothing but the rate of change of delta y with respect to delta x, right? Now this can be written as dy by dx also. Instead of writing the triangle, we can say dy by dx. We can also write something like this, delta y by delta x, or we can also write it as f prime of x. There are many different ways in which it has evolved, but the core thing is this. Think enough for today. Bye for now. Please go to the about page of my channel, and here you will find various links for each topic. These are Excel workbooks which I have been using in many of my videos. Download it and practice.